Hello student and welcome you all. So in the many problems I have solved the problems when a shaft is subjected to bending and torsion. So in the today class I am going to explain you if the same shaft is subjected to bending, torsion, and in addition if it is subjected to end thrust. How to solve the problems, and before that we will come to know the procedure for solving these type of problems. For example, if there is one circular shaft, it is subjected to bending moment, like when you apply the load, so the curvature can be formed here. So the stress in the material can be a bending stress. Okay, and similarly the same shaft when it is subjected to torsion or twisting moment, the shaft may be twisted and there will be producing the internal angle of twist and all. That also we have studied bending equation and torque equation. Separately we have a class on this. Okay, now when these two are combined, so we have considered there is an equivalent bending moment and equivalent twisting moment. Using that equation we have calculated the unknowns. So in this problem, in this class, we are adding one more load, that is the end thrust load, means axial applied load when the shaft is subjected to, and additionally there is an axial load, like the load can be, you can take W or P, F, anything you can write down. So when this is subjected, when the axial load is applied, and also along with that there will be bending moment and there will be torsion. So now that shaft, it can driving the it can drive some gears or something. So when it's a combined for all these loads, so there will be combined stresses can be developed. Now in this case, what are the different procedure to solve this type of problems? Okay, so first, as you know that basically when the shaft is subjected to axial load, so we can say that is a direct stress. So it can be written as just a sigma we will write, or for understanding you can write A for the axial is equal to, as you know, the stress for the axial load divided by area. So load is applied as W and area we will write as A. Now for a circular shaft, the area it will be pi by 4 d square is the area of a circular shaft. Now the same equation can be taken as the 4w by pi d square. We can write like this. Okay, so now sigma A is equal to 4w by pi d square. Now to combine the bending and the axial stress, so you should combine these two first, axial and bending. Okay, like for combined bending and direct stress, because for this axial thrust we got the direct stress. So now let us say for these two combination we will write a sigma 1 for the combined of bending and thrust. So bending stress can be, first we will write sigma B as bending stress, and for direct stress sigma A. Okay, so for bending stress, so as you have derived the equation, when a shaft is subjected to and load and bending load. So what is the equation for the bending stress? We have derived, that is 32 m by pi d cube. This is for a solid shaft, when the shaft is subjected to bending. This equation we have derived later, plus sigma a, just now you have derived, that is 4w by pi d square. So this is for combined bending and direct stress. Now again we will go to torsion equation. For torsional means we produce the, when shaft is subjected to torsional forces, we produce which type of stresses? We produce the shear stress due to the torsion. Now for this also we have derived using the torsion equation, that is T by J is equal to tau by R is equal to G theta by L. Using that equation, by considering the strength, we have derived the shear stress, that is tau is equal to 16T by pi d cube. Okay, so now these two for bending and thrust, and this is for the torsion. Okay, so like that there will be basic procedure in calculating the, when all different forces are acting on the shaft. So you need to get separately calculate like this. Later in the problem I will tell you how to solve and what is the different equation you have to adopt when you are considering the equation. Okay, so in the part 2 I will explain about the one problem on this. Thank you.